All right, so let's go to chapter 2. In chapter 2, we're going to talk about relations and functions. And okay, a function is a relation, right? Which means it's a relationship between numbers, like one set of numbers to another set of numbers, in which each element in the domain has exactly one pair in the range, right? What does that mean? Here we have all these numbers in the domain, and you see how each one of them points to one other number. So the -3 only points to 0. The -2 only points to this number 2. 0 only points to 4, right? 1 only points to 6. That's what makes it a function. Right. Now, it can be that two numbers point to the same number, but that's okay, right? Because we'll take a look at some another example right now where it's not okay. All right?
How do you know what maps report?
You will know. Like you'll see throughout this lesson. Okay. So the domain then is always the set of all x values that work or exist in a function or a relation. Okay, so always relate the word domain to the x values. The domain or the x values are also called the independent variable. All right, and if I'm graphing something, then all of this goes on the horizontal axis, right? So x, the domain, the independent variable, all go on this horizontal axis. Now, the range is the set of all of the y values, and those are called the dependent variable, and all of those always go on this horizontal axis. So the y, the range, the dependent variable are all on that vertical axis. All right? Okay. Whenever we express domain, we have to always go in ascending order, increasing order. Now, going back to Liam's question, this is not a function. Why? Do you see how one number here is going to two different items in the range? That's why it's not a function. So here, it's okay that two numbers are pointing to 6, but it would not have been okay if, let's say, -1 pointed to two different things. Does that make sense? Like, you can't have a number fork out and point to two different things. Okay? All right. So let's, oh, how come these went away again? They're more aligned on yours, right? Let me see. Can you flip? Yeah, mine went off of alignment. Let me bring up that one here. Okay, here. So if you take a look at this, right? Look at this first one. Is it a function?
Yeah.
Yeah, it is a function because each number only points to one other number. So yes, it is a function. Okay. So yes. What about this one? Is it a function? So what you want to know is you want to look at all of the x values. You want to ask yourself, do any of the x values repeat with different y's? So for example here, the 3 and the 3 repeat. And do you see how they have different y values? That means it is not a function. Not a function. Okay? Because x values...
So each domain can only have one range.
Yeah, you're right. Each number can only be paired with one number. So x values repeat with different y's. Okay, take a look at this next one. Is this a function? Do any of the x values repeat?
No.
No, so it is a function. Okay? Now, you can have relations that are either discrete or continuous. Discrete just means you have individual points. Okay? They are not connected. A continuous relation means you've got an infinite number of points and they are connected. So how many points are on this line? An infinite number and they are all connected, right? So discrete, just random points. Continuous, you literally have like a continuous line or curve. Okay? Okay, so take a look at this one. This is a discrete function. We want to know what the domain and range is. So the domain, remember, it's all the x values, right? So what we do is we do a curly bracket, okay? Cute little curly bracket. And we're just going to put in all of the x values, but we're going to go in like increasing order. So -4, -3, 0, 1, 3. The range is going to be all the y values. So here I have -2 twice. I only write it one time. 1, 2, 3. All right. Okay, so what's the domain of this next one? You tell me. Right, and if we go in increasing order, -3, -2, 3, and 4. All right, and then the y values are what?
-5, -3, -2.
Right, -5, -2, and 5. Okay, that's the range. Okay, so is this a function?
Why didn't you put the 2 down? The -2 down.
I did. There, which one? For here?
Oh, because
There are two of them. You only ran it once. Is this a function?
No.
No? Do any of the x's repeat for b?
Yeah.
The x's don't repeat, so it is a function.
The y
Right.
is repeating.
That's okay. You only look at the x's, okay? So it is a function. So that's how you can tell if you've got like points like that. What if you've got a graph? How can you tell if something is a function if you have a graph? Well, that's by this vertical line test. The vertical line test says this: if you have a graph and if you draw on that graph a series of imaginary vertical lines, each vertical line should pass the graph exactly one time, right? So this is a function, okay? This, you see how when I draw vertical lines, it passes the graph more than once? Not a function. All right? So take a look at this one here. The first one, is it a function? No. What about the second one? Yes. Here? Oh, sorry. So if you do a vertical line, it crosses more than once, so no. Here, if you draw vertical lines, it crosses the graph. Each vertical line crosses the graph only once, so yes. Here? Yes, because if you do a series of vertical lines, they would only cross the graph at one point.
No.
Here? No, because if I draw a vertical line here, you see how it crosses the graph at 2 points? So it's not a function.
So it has to be like, if you so like imagine drawing a vertical line at any part.
Yeah, it's an all or nothing deal, right? Something could be okay like everywhere, and then it can fail one time and done. Okay? Okay. So, dependent and independent variables. So to repeat, the variable that represents the domain is the independent variable. The variable that represents the range is the dependent variable. So here, in this equation, what is the independent and dependent variable? So if I were to graph this, which variable would be horizontal and which variable would be the vertical axis? So independent horizontal, which one would be? Would it be X or Y? X. And then the dependent would be the Y. Now, what is the domain and range? So here we have to kind of stretch our mind a little bit. We have to visualize the graph of this equation. When you graph that, what kind of graph do you think you would get? That's a y equals like mx plus b, right? You would get like a line graph, something that looks like this, right? Yeah? So, okay, so let's take a look at that. When I graph this, I get a line that looks like this. Okay? So now let's talk about the domain and range. Okay, let's talk about domain first. That's the horizontal axis. When I take a look at this, this is going to expand horizontally forever and ever and ever and ever, right? So that means wherever I am on the x-axis, there's going to be a graph there, right? Because it's going to expand horizontally forever. It's going to cover the entire region of the x values, right? So I say the domain is all real numbers. Okay, that's a lot to write down. Do you guys know the R, right? Yep. Okay. Range. This line is also going to expand vertically, and it's going to take up all of the y values from negative infinity to positive infinity. So the range is also all real numbers. We're going to do a lot more with this. All right. Let's do some function notation. Here, I have a function, I have an equation, y equals blah, blah, blah. But in algebra, sometimes instead of the y, we write f of x. Okay, you guys have seen that before, right? F of x, okay. So when I have a function like this, f of x is equal to 2x minus 3. If I ask you what is f of negative 6, I'm basically asking you what is the y value when x equals 6, right? So here for f of negative 6, what I'm going to do is I'm going to take that negative 6 and put it in place of all of the x's. So it's going to be 2 times negative 6 minus 3. Okay. Huh? No, that's it. Now you want to like do the operation and see how much that is. So that's negative 12 minus 3, negative 15. Okay? Okay, so here. Now I have a new function. F of x is 3x minus 4. I want to find f of 4. So I'm going to put that number inside into each of the x's there. So it's going to be f of, I'm sorry, not f of, it's going to be 3 times 4 minus 4, right? Yeah, that's 12 minus 8. Okay, let's do the next one. F of 5 means 3 times.
Wait, how do you get minus? Minus 4.
Minus 4.
Oh, sorry. Sorry. Okay, here, it's going to be 3 times 5 minus 4. 11. Okay? All right, now take a look at this one. It's f of negative 3a. So I'm going to put that in the place of x. So it's going to be 3 times negative 3a minus 4. Okay, so now this is going to be negative 9a minus 4. That's it. Okay, now f of n plus 1. Now I put n plus 1 instead of the x. So 3 times n plus 1 minus 4. Yep. Yep. So it's double-sided. You just need to put your calculator away. Okay. So distribute the 3. This is what we were doing last chapter. You guys are experts here. So 3n plus 3 minus 4, 3n minus 1. Okay, for this next one, f of c, it's going to be 3 times c minus 4, and that's it. Okay? All right. Here, I have 2 different entities. I have an f of negative 6, which is separate.
So 3 times negative 6 plus 10 minus 4.
Right. So it's going to be 3 times negative 6 minus 4 plus the 10. Negative 18.
Does it matter which one you put first or not? Like obviously like it's the same thing, like when you're physically writing it.
Yeah, well, in case like when these get a little bit more complicated, then it's best to just finish with this and then add this. So how much is that? Negative 12. Okay. All right. So go ahead and do these 2. Go ahead and do these 2 on your own. Now you have a more complicated function, right? So go ahead and do these 2. Remember when you put negative 2 into the function, put negative 2 in parentheses, right? Huh? Yes. So it would look like this. 2 times negative 2 squared minus 3 times negative 2 plus 1. All right, so go ahead and continue. Okay. So with your calculators, go ahead and turn them on and make sure you are on this screen. Okay? Is everybody on the screen? Do you have your calculator? Okay. Do you have your graphing calculator?
Yeah, but it's dead.
Okay. All right. So we are going to be using them more often. Make sure next week, Tuesday, everybody has a working calculator. If you have your calculators, please turn them on right now. To go to a graph, this is the best button, for quick graphs, right? Like you're on the go, you're like, let me just graph this really quickly. Like this is the best way to do it, okay? We're gonna press this, and when you do that, it alternates or toggles, right, in between a workspace, and then if you keep pressing it, like if you press it again, you get a graph. Press it again, you get a workspace, and so on. So when you do this, you should get something that looks like this. In here, you can put any function that you would like to graph. Now, suppose you don't get that bar on top. What you would have to do is press tab, and you do get it over there, okay? Now, suppose I want to graph something. Suppose I want to graph, I don't know, y equals 7x plus 4. Okay? So here's what we're going to graph. Y equals 7x plus 4. That's the same as, f of x equals 7x plus 4. Right? Same thing. So in here, you just type in 7, and then the variables are here at the very bottom, which you can't see apparently. Okay, so you're gonna type in 7. X is at the very bottom here. They're the black keys at the very bottom. What was it? Minus 4, is that what I said? Plus 4.
Wait, I'm slightly confused. My calculator.
And when you graph, it should look like this, huh?
Yes. It says this. I don't see anyone else where I can write.
Press escape. Okay. So press the dock button. Now press B. Put the keypad down here. B. Okay, now that. Oh, okay. Oh, okay, it did. So go back to your graph. The toggle in here. Yep. Now.
Okay.
Now do it. Okay. Everybody was able to graph this, right? Okay. And so now you can see this equation. Would you be able to figure out what the domain and range is for this equation? Okay. Remember what domain is. Domain is what x values does this graph cover. So now this thing is going to keep expanding forever and ever and ever. And it's going to cover like the entire horizontal region, right? So the domain is going to be all real numbers. And what about the range? As this expands, it'll cover the entire vertical region. So it'll be all real numbers. Okay? Now, press tab, everybody. Press tab. And press the up button. We're going to delete this. Press Control, the blue button. Delete. Okay? Now there is no function. Now I want you to put in x squared minus 3. Okay, so x is at the bottom. Square is right to the right of the left of the 4. What was it? Minus 3. Enter. You should get this. Okay, let's talk about domain and range. What would the domain of this be? So domain is how much of the horizontal region is this graph going to cover? All of it, right? So this is going to keep expanding like this. So it's going to cover the entire horizontal region here, right? So the domain of this is going to be all real numbers. What about the range?
Not all of it.
Not all of it. So let's take a look at vertically. Which region does this cover? Well, there is nothing here right until that point, and then it'll look like it'll cover everything else above it, right? What number is that? 1, 2, negative 3. So it's going to cover everything above negative 3, right? So I say y is greater than or equal to negative 3. Okay?